Alright, let's work through a couple of examples here. And we're going to start with just looking at types of data. So, key here is to look at their hint. Data that are discrete often start with the words the number of. The number of pairs of shoes you own, as that hint just said, is going to be discrete. Quantitative discrete. It's a number and it's countable. That's going to be a useful tool. Countability. It's not divisible either. You can't have a half a pair of shoe. For B, you're going to have the type of car you drive. How would you answer that? It's not going to be a number. It's going to be a description or a name, and it's going to categorize the car you have. That's going to make it qualitative. And lastly, you're going to have the distance it is from your home to the nearest grocery store. There's an infinite number of possibilities. You can go just a little farther and be just a little farther from that grocery store, or just a little closer, and it's not countable. You could do different units. There's an infinite number of distances. And now we'll take a look at some sampling types and just kind of familiarize yourself with these as well. Sorry, let me pull this up on my laptop here. Alright, sorry for that delay. So, let's talk about A here. A soccer coach selects 6 players from a group of boys aged 8 to 10, 7 players from a group of boys aged 11 to 12, and 3 players from a group of boys aged 13 to 14 to form a recreational soccer team. He's taking a sample out of all the boys, right? All the boys soccer players. And how is he taking that sample? Well, he's breaking into groups so he has equal representation. Or maybe not equal, but representation from all the groups. That would be a stratified sample. B, a pollster interviews all human resources personnel in 5 different high-tech companies. So he wants to go to the 5 different high-tech companies before he asks. He knows where he wants to draw the sample from. That's going to be a cluster. Skip over D or C. We'll go to D. A medical researcher interviews every 3rd cancer patient. Anytime you hear that, think of systematic. It's not random. It's drawn according to a specific number. For E, we have a high school counselor uses a computer to generate 50 random numbers and then picks students whose names correspond to those numbers. That's a great way to come up with a simple random sample. So don't get it confused with systematic. It's going to be according to an algorithm that he doesn't know, right? It is completely random. Everybody has an equal chance of being selected. And lastly, F, a student interviews classmates in his algebra class to determine how many pairs of jeans a student owns on average. Well, who's he asking? People in his own class. That might be, if you're thinking of a population as the entire U.S., and he's asking people in his own class, well, if it's winter in his own class, he's in a cold area. A lot of people are going to own more jeans than if they're in Hawaii. So this sample is convenient. It's who's near him. It's really simple, straightforward, but it's not necessarily the best representation.